Good morning students. Today we are going to learn about the topic is pressure due to a liquid column. Pressure due to a liquid column. Okay. So what is liquid column? A tall beaker. A tall beaker is filled with liquid. Okay. So that it form a liquid column. It form a liquid column. Do you understand? So the tall beaker is filled with a liquid so that it forms a liquid column. Okay. Now you take a tall beaker. The area of cross section at a bottom is A. Next, rho is the density of the liquid. Rho is the density of the liquid. Which is the height of the liquid. Do you understand? So the area of cross section is A. The density of the liquid is rho. And height of the liquid column is h. Already we know thrust. What is thrust? Force acting on the perpendicular surface is called thrust. Force acting on the perpendicular surface is called thrust. Okay. So the thrust at the bottom of the liquid column we are considered F. So F is equal to weight of the liquid. F is equal to weight of the liquid. So F is what? F is a force. Force is equal to mass into acceleration due to gravity. Mass into acceleration due to gravity. Okay, now you are considered mass. What is mass? Mass is equal to density of the liquid into volume. Density of the liquid into volume. Okay, now you are substitute here. So, now you are considered the volume of the liquid column. Volume of the liquid column. So volume is equal to area of cross section into height. Area of cross section into height. So height, here listen, V is equal to A into height. Okay. So M is equal to what? M is equal to rho into V. Now you are substitute the value. Rho is into V is equal to A into height. So M is equal to rho into A into h. Okay. Next we are considered force. Force is equal to formula. Force is equal to M into G. Mass into acceleration due to gravity. So here M is what? M is equal to density of the liquid into area of cross section into height. So M is equal to rho into A into h into G. Okay. So now the force is equal to rho into A into h into G. Okay. Next pressure. Pressure formula P is equal to F by A. Here you are considered thrust. So P is equal to, pressure is equal to thrust by area. Thrust by area. So thrust is equal to formula M into G. Thrust we are considered F. Yes. So M into G divided by A. M into G divided by A. M into G divided by A. Here M is equal to value rho into A into h. Yes, you write now. Rho into A into h into G divided by A. So A cancel. We are getting the answer rho into h into G. Okay. So now you write h rho G. So pressure due to a liquid column P is equal to h into rho into G. Okay. So the pressure of the liquid column depends on depth, density of the liquid and acceleration due to gravity. So clearly we are understood. Pressure of the liquid column is depends on depth, density of the liquid and acceleration due to gravity. Okay. So pressure depends on depth. So pressure does not depends on A. Okay. A is what? Area of cross section. Okay. So pressure depends only on depth. The pressure does not depends on A. Do you understand? Calculate the pressure exerted by a column of water of height 0.85 meter. Density of water rho W. Density of water is equal to 1000 kilogram meter power minus 3. And kerosene of same height. Density of kerosene rho K. Rho K means what? Density of kerosene equal to 800 kilogram meter power minus 3. Now, what do you find out? Pressure. So the solution, pressure due to water. Pressure due to water. Pressure is equal to formula H into rho into G. Okay. So pressure due to water is equal to H into rho W into G. Pressure due to kerosene is equal to H into rho K into G. Here H is what? Height 0.85 meter into rho. Density of water is equal to 1000 kg meter power minus 3 into, and here G, gravitational. Now you write here G is equal to 10 meter second power minus 2. Okay. So G is gravitational force 10 meter second power minus 2. Here calculate the value 8500 Pascal. Okay. Next. Here H into rho K into G. So H is equal to 0.85 meter into rho K. Rho K means density of kerosene is equal to 800 kg meter power minus 3 into gravitational acceleration due to gravity 10 meter second power minus 2. So what's the answer? 6800 Pascal. Okay. Now we are going to learn about the topic is atmospheric pressure. In previous class we have studied the atmospheric pressure. Yes. So okay. Now what is atmospheric pressure? The earth is surrounded by the layer of air up to certain height. How much? Nearly 300 kilometer. Okay. So this layer of air around the earth is called atmosphere of earth. Okay. So once again, earth is surrounded by the layer of air up to certain height, nearly 300 kilometer. Okay. So this layer of air around the earth is called atmosphere of the earth. Okay. Since air occupies mass. Yes or no? So air occupies mass and space. Okay. So air has space and weight. Yes or no? So it extracts one pressure. This pressure is called atmospheric pressure. Okay. So what is pressure? Force acting on the unit area is called pressure. Yes or no? So force acting on the unit area is called pressure. Okay. Now here listen. Air pressure and density are higher at sea level because a taller column of air pushes down. And here listen, air pressure and density are here higher and here lower at the high altitude because a shorter column of air pushes down. What do you understand? Now here you are listen. We have considered the sea level. Here now we are considered the mountain level. Okay. So when we go to the higher altitude, mountain places, okay, here the pressure is decreases. When we go to below the sea level, the pressure is increases. Do you understand? Here listen, when we are go to the high altitude, example mountain, higher altitude, the pressure is decreases. When we go to below the sea level, the pressure is increases. Okay. So one atmospheric pressure is equal to 101.3 kilopascal. One atmospheric pressure is equal to ATM is equal to 100.3 kilopascal. Next we are going to learn about the measurement of atmospheric pressure. Measurement of atmospheric pressure. Okay. So the device used to measure the atmospheric pressure is called barometer. The device used to measure atmospheric pressure is barometer. Okay. Here the mercury barometer. The mercury barometer is designed by Torricelli. Okay. Here listen. It consists of a long glass tube. Okay. Here one end is open. One end is open and other end is closed. Okay. Then it is filled with mercury and turned upside down into the container of the mercury. Here also it is filling with the mercury. Okay. This is done by the closing the open end of the mercury. Okay, it is filled up with the tube with the thumb. So and then opening it after immersing it into the thought of the mercury. Here listen, how did it is working? The barometer works by the balancing the mercury in the glass tube. Okay, against the outside air pressure. So if the air pressure increases, more of the mercury turns up into the tube. Okay, and if the air pressure decreases, more of the mercury drains from the tube. Okay, here listen, vacuum. So the vacuum cannot extract any pressure. Okay, so this type of the instrument can be used in a lab or weather station. On a typical day at sea level, the height of the mercury column is 760 millimeter. So let us calculate the pressure due to the mercury column is 760 millimeter, which is equal to the atmospheric pressure. So the density of the liquid is 13,600 kilogram meter power minus 3. Now you are calculate the value of pressure. So P is equal to H into rho into G. H is equal to 760 millimeter into and rho is equal to 13,600 kilogram meter power minus 3 into 9.8. G is equal to 9.8 meter second power minus 2. Here millimeter, it is converted to the meter. So 10 power minus 3 we have multiplied. So 760 multiplied 10 power minus 3 meter into 13,600 kilogram meter power minus 3 into 9.8 meter second power minus 2. So we are multiply all the values, we are calculate, then we are getting the answer 1.013 into 10 power 5 Pascal. Okay, so 1 ATM is equal to 1.013 into 10 power 5 Pascal. Okay, so the large value of pressure we can use 1 unit, 1 bar is equal to 1 into 10 power 5 Pascal. Okay, so 1 ATM is equal to 1.013 bar. So the unit of pressure is Pascal. 1 ATM is equal to 1.013 into 10 power 2 into 10 power 3 Pascal. So now you here it is converted to the kilopascal. Okay, so 1.013 into 10 power minus 2 kilopascal. We are calculate 101.3 kilopascal. Do you understand clearly? Okay. Number 3. A mercury barometer in a physics laboratory shows a 732 millimeter vertical column of mercury. Calculate the atmospheric pressure in Pascal. Given the density of the mercury, rho is equal to 1.36 into 10 power 4 kg meter power minus 3. The gravitational acceleration due to gravity G is equal to 9.8 meter second power minus 2. Okay, so the solution, what do you calculate here? Calculate the atmospheric pressure. So rho is equal to H into rho into G. H is equal to value 732 it is converted to meter into 10 power minus 3 into rho is equal to 1.36 into 10 power 4 into 9.8. So we are calculating to get the answer 9.76 into 10 power 4 Pascal. Otherwise we are write it here 0.976 into 10 power 5 Pascal. Okay. Next we are going to learn about gauge pressure and absolute pressure. Okay. So when tire pressure and blood pressure are measured using this instrument. Okay. Here they show the pressure over the atmospheric pressure. So here listen, for pressure higher than atmospheric pressure. Here for pressure lower than atmospheric pressure. So in higher than atmospheric pressure, the absolute pressure is equal to atmospheric pressure plus gauge pressure. Here lower than atmospheric pressure is equal to absolute pressure is equal to atmospheric pressure minus gauge pressure. Okay. Now we are going to learn about Pascal law. It is very important. Okay. The Pascal principle is named after Pascal in the year of 1623 to 1662. Okay. This law states that external pressure applied on incompressible liquid is transmitted uniformly throughout the liquid. Once again, this law states the external pressure applied on incompressible liquid is transmitted uniformly throughout the liquid. Okay, here listen. Pascal law demonstrate with the help of glass vessel. Okay, glass vessel. It having the holes all over its surface. It having the holes all over in the surface. Now you are filling with water. Okay. Now push the piston. Now you push the piston. Okay. Here the water is rushes out. Here the water is rushes out of the holes in the vessels in all direction. Okay, in all direction with the same pressure. So the force applied on the piston, exerted pressure on the water. So this pressure is uniformly transmitted equally throughout the liquid in all direction. Okay, so it is used to the various machines. So this law, it is very important. This law states the external pressure, we are applying the external pressure applied on the incompressible liquid is transmitted uniformly throughout the liquid. Okay, it is very important. So you are study very carefully. Okay students, today class is over. Thank you.